From today, we are going to study some examples of SimPy simulation. So from this week, the first class is to introduce about the what is the examples, and I will give you homework that have to be customized from the given problem. So let's start with the first example. The name of this example is Bank Renege. Renege. Firstly, let's see the animation. It is about the bank system. The customer is arriving at the bank and doing his jobs. And sequentially, the arrived customer is going to the counter. But during those process, the one who does not endure the waiting time, that customer will leave the bank without being serviced. So in this example, there is 3 parameters. First 2 parameters is inter-arrival time and service time. And one more parameter is patience time. We will define the patience level. It means that in order to generate a random variable of the patience level, we will define the minimum and the maximum value of the patience during those time that customer can wait. So in order to implement this example, we have to know one key concept. It means that we have to yield. Yield means that generate an event that only the earliest of the time the customer lose patience or the time the customer can get to the counter. It means that if once the customer arrives at the bank, there may be 2 incoming events. First event is the time during a time the customer can wait and go to the counter. The other time is the customer lose his or her patience. So in this case, we will use just one yield function. So we need to catch the earlier events that is coming. Before the simulation, we don't know which is the earlier event. The earlier events will be determined during the simulation progress. So in order to implement this kinds of event, the selection of the event, we have to use the conditional events. There are 2 kinds of conditional events. First one is any of. Any of is a variable in the SimPy event and triggers based on the earliest event among several events. Usually you can use the logical operator as this bar, which means the OR relation. So we can use like this, yield and note the 2 events, and between these two events, we add this bar, which means the OR relation. Or also the timeout is also one of event. So we can use these kinds of command. First, the event 1 and the timeout. If we use this event, that if the event 1 is coming earlier than 2 time unit, this will generate event 1, even though the time 2, the 2 time unit is not reached. If we, even though we use not this kinds of event generation, how about this? If we add this phrase in the code, what will be the result of this generator? It's not difficult. It's very, this event is exactly same with this one, because 2 events are fixed with the time unit 1 and time unit 2. So in this case, this yield generator never wait until time unit 2. So this phrase is exactly same with this. However, the events that we cannot predict before the simulation, so in this kinds of phrase, we'll generate the event in random way, which means the earliest events will be returned to the generator. And next conditional event is all of. All of events, this is a variable in the SimPy events and triggers based on the event that comes last among several events. So in this case, you can use the logical operator, this, what do you call this, ampersand, is it right? And this, logically, this means the and relation. So if we use this phrase, then this yield generator will wait until both events are finished. So let's see the animation. In case of any of the conditional events, the earlier it's let's see like this. In case of any of events, the first finished events will be returned to the result variable, in spite of the event 2 is not reached. But in case of all of conditional events, the both events have to be finished. Then after the completion of both events, these 2 events will be returned to the result variable. And in our example, we will see why we need this return value. Okay. And this example can be referenced at this address. Let's see the code before the execution in the pie chart. this is the whole code. And the name is bank renege. Samuel, what do you pronounce this word? Renege?
Renege.
Renege?
Renege.
Renege?
예, 맞아.
Thank you. Renege, bank renege example. And this example covers the resource and including the conditional events that we just have studied. And scenario is as follows. A counter with a random service time and the customer who renege. Based on this program from the bank, blah, 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 we will use the random package in order to generate random variable. And also we'll use a SimPy package. And this part is the information, the variable definition that we will be use. The random seed is 42. You can change this random seed. If you by changing this random seed, we can simulate more the various various cases with the different seed of random numbers. And in this case, we define the new customer number as 5, but anytime we can change this number. And interarrival time of customers is 10. And moment, timeout variable. Okay, and we have to define the patience level in order to generate a renege events. In this case, minimum patience time is 1, and the maximum patience time is 3. So in our code, we will, where is it? We will requirement renege patience. Here, this is this part. Patience is defined as a random variable, and the uniform distribution is used, and required parameter of a uniform distribution is the minimum number and maximum number. So this distribution will generate any random number between the minimum and maximum value. That minimum and those minimum and maximum value were defined as 1 and 3, this example. And this is the starting part of the entire code. So we define the seed number of the random generator with the global variable random seed. And also, in any case of the SimPy simulation, we have to define, we have to create environment variable. And in this part, we'll start the process and run. And there is a counter that will be handled as a resource. So in here, counter is defined as a resource variable, and initial capacity is assigned as 1. And the body of the process that will be called from the source is input to the parameter of the process of the simulation. and argument is number of customers and inter-arrival time of customers and the counter as a resource. Okay, that's one. So if in this code, if this source is called, then this function is being executed. In this function, there is a for loop with the number of iteration. This iteration number is defined as the number of customers because this number argument is connected with the second argument in the called part, the used part. This new customer is passed to the number, and in here the new function is being called, that is customer. Customer function is defined at this part. Can you see the pointer, laser pointer? In this part, by calling this customer, the customer function will be executed. And as the arguments for the customer, the name is defined. And when the name is defined, the number, the order of number is being passed together this character variable. And also the counter as a resource is also being transferred to the customer function. And time in bank, it means that the service time is defined as a deterministic variable, not the stochastic variable in this case. It's deterministic as 20 time unit. And calling this customer is being executed with the process function. Actually, process is also one of kind that is belonging to the generator. So generator execute the customer function, and in order to make a term between each arriving customers, it means that inter-arrival time is defined as a random variable, and there is exponential distribution. And in this random package, when you use a random package, and by calling the function that is belonging to random package, for the exponential distribution is exponentiate. And it's a little bit confusing, but argument is the reciprocal number of the average time. So we have to define as a reciprocal number of the inter-arrival times. But if we use the other kinds of package about the stochastic distribution, this argument type can be changed. So please be careful when you use any kinds of stochastic distribution function of a specific SimPy package. And this time is passed to the timeout generator here. That is the function of the source. So Next is, and last is the customer function, and argument is the name and counter as a resource, and fix the time in the bank, that is a service time. And first line is the arrival time. And this arrival time is saved the simulation time at this point. And for this, we use the now variable of the environment. That is the actual real time. This is a simulation time. And print the announce, here I am, of any customer. And from this, we use the with what do you call this phrase? We will use with and as phrase in order to use the resource. So if we define the counter, if we define the counter as a resource, so we can use request function of the resource. And by using of this with and as relation, this resource, this request event is handled as a REQ variable in this block. This is the event, required event. It means that by the declare this the REQ as a counter that request, this REQ will handle the requested resource inside of this block. Next is the patience time that is generated in random number, and that distribution is uniform with minimum and maximum value. And next line is that we just saw in previous slide, that is a conditional event. So by declare the two events, first event is requirement, request, and second event is timeout, and the time is the patience that is passed from this line. So in this line, this program will wait until the first coming event between this request or timeout. And as soon as any events from these two events, the finished events will be stored in this result variable. And we will use this variable in this block, if and else block. And before going to this if else, we have to record the time that this customer have waited. So waiting time is recorded as a difference between current simulation time and the arrival time that was already saved at this variable. So this value is go to this, and by extracting from the current time, we can check the waiting time that this customer waited in the bank. Next is the by use of the result variable, depending on the what events is being stored in the result variable, different block is executed. If this generator is finished with the request, it means that before the end of the patience of the customer, the counter was first the available before the patient's time. So this request event is being saved, is stored in result variable. So this part is being executed. So print the waiting time, that is this variable. Also current time and the name of the customer are printed together. And I'm sorry that I said something wrong in previous section, previous part of this timing bank. This is not fixed time. This is the average value, and in customer function, the service time is being used as the exponential distribution. So this value, timing bank, is the average value. And this average value is passed to the customer function. And by use of this average value, the random exponential variable as a service time is being created as a TIB variable, and yielding the generator will consume a time of t amount of this variable. And after the completion of the service, the print function will bring out this message. And if in this line, the bank account is not available until the end of the patience, then these events will be saved in the result variable. And in this if block, this part will be executed, and only one execution, there is a printout. The renege after the patient's time will be printed out. In this case, there is no service, and logically this means that this customer cannot be serviced, and he leaves. He or she left the bank without being serviced. Okay, this is very a little bit simple example. So in order to summarize the entire code by use of the schematic diagram, the most outside of our program is environment object. And we create the source process inside of the environment. And by creating the source process, this source function is being executed and start with creating the customer process. From this point, the customer function is being called, and inside of the customer, most important part of this problem is the conditional event. So the earliest one is being selected and recorded. So if the timeout event is finished earlier, then this timeout will be executed. And if the service is available before the patience is over, then this require the request will be executed and service time will be consumed in the bank. And step by step, the arrival time between every customer will be made as the exponential distribution, and continue until the last customer is arrived and serviced or left. That is the entire structure of this code. Simply, the most external boundary is the environment object, and inside of environment object, this example contains two functions. So it's not so complex, and I think all of you may understand the details of the code and progress the flow of the simulation. This is the homework. I will explain this homework at the end of this class. So we will execute the actual code. The code is exactly the same that we have just seen. So, 소연이는 뭐 타고 왔어? 순간이동을 했네? 안 들려. 야, 아까 20분 전에 출발한 거 아니야?
아닙니다. 저 한 10시쯤에 출발해서 방금 막 도착해서 앉았습니다.
순간이동한 줄 알았네. Anyway, this is the same code, so I'll just simply run this code here. It's very simple. At time 0, the first customer is arrived and print out this message. And in this case of the customer, there is no waiting, because at the start point of the simulation, all the counter, not all, there is only one counter anyway, counter is available because no customers were there before the first customer is input to the bank. And after this time, maybe this time maybe the generated service time, and after this time the finished message is being printed, and this time 10.2 blah blah will maybe the generated random time, random arrival time. So second customer is arrived, and also in this case the first customer is already finished his work and counter may be available, so this customer also do not waiting. But when this second customer is being serviced, the third customer are a little bit confusing, because the the order is started with 0. So this 2 is the third customer. So third customer is arrived at this time before the completion of the service for the second customer. And this third customer gave up because his patience is being fooled. So that in this case, the patience time may be generated as the amount of this time. So he reneged and left the bank. And at this time, the service of second customer is completed. So 10.2 and 23.7 are about 13.5 time is being consumed for the second customer. And at this time, the first customer is arrived and he or she does not wait because the counter is available and finish this service, and first customer is arrived and no waiting and finish it. This is the progress of this example. So I think that this example is very, very straightforward. So if you simply understand these conditional events, you can design and implement any type of problem similar with this bank example. You can implement, I think.